$12,749. Tesla didn't wake up one morning wanting to build a cheap electric car. The market forced their hand. According to Tesla's January 2nd report, analyzed by CNBC, the company delivered only 418,227 vehicles in Q4 2025, down roughly 16% year over year and below Wall Street expectations. For the full year 2025, Tesla delivered 1.64 million vehicles, an 8.6% decline, marking their second consecutive year of falling sales. Meanwhile, BYD surpassed Tesla to become the world's largest EV seller with over 2.26 million vehicles. With the U.S. EV tax credit now expired, the game has fundamentally changed. It's no longer about brand prestige or flashy technology. It's about actual selling price, adequate range, and the lowest possible cost of ownership. To hit a price point around $12,749 after available incentives, if eligible, Tesla must implement 7 major changes spanning design, interior, battery technology, manufacturing processes, and software. In this video, I'll analyze each change from an engineer's perspective. No hype, no dream selling. And if you don't want to get fooled by clickbait headlines about cheap EVs, subscribe right now because this channel exists to help you buy right, not buy wrong. Change number 1. Design shifts to compact crossover. Tesla isn't following the cheap hatchback playbook that everyone expected. Instead, leaked supply chain documents and Fremont factory activity suggest they're pivoting toward a compact crossover format. Here's what that factually means in practical terms. The rumored dimensions put this vehicle at approximately 4.2 to 4.4 meters in length, roughly 15 to 20 centimeters shorter than a Model 3, but with noticeably higher ground clearance. The silhouette appears to lean toward a coupe fastback profile rather than a traditional boxy SUV shape. Design elements reportedly include a continuous LED light bar across the front and an extremely minimalist body structure enabled by next-generation gigacasting technology that reduces panel gaps and eliminates unnecessary joints. Now, here's the part that matters for older drivers. A crossover design isn't just about looks. The higher seating position makes entry and exit significantly easier, especially for people dealing with knee problems, hip replacements, or general mobility limitations. You're not dropping down into a low sedan or climbing up into a tall SUV. You're stepping naturally into a vehicle that meets you at a comfortable height. That elevated driving position also improves sight lines dramatically. When you're sitting higher, you can see over traffic better, judge distances more accurately, and feel more in control, especially in parking situations or heavy traffic where spatial awareness becomes critical. For someone who's been driving for 40 or 50 years, that sense of control matters more than any spec sheet number. The fastback roofline might sound like a styling compromise, but it actually serves a functional purpose. By tapering the rear, Tesla reduces aerodynamic drag without sacrificing meaningful headroom in the front seats, where you spend 95% of your time. The real engineering win here is weight distribution and structural rigidity. A smaller, taller vehicle built around large single-piece castings creates a stiffer chassis with fewer failure points over time. So when Tesla says this is a compact crossover, they're not just chasing a trend. They're building a vehicle format that balances cost efficiency with real-world usability for people who need simplicity, visibility, and ease of access. Bottom line, cheap price, but not cheap execution. This design serves actual daily use. Change number 2. Small LFP battery pack. Tesla is betting on a 53 to 55 kilowatt-hour LFP battery pack. Not because they can't build bigger, because bigger doesn't make financial sense for this vehicle's mission. The target range sits around 250 to 310 miles per charge, depending on drive configuration and conditions. That's not class-leading. It's not meant to be. It's optimized for daily driving, not cross-country road trips. Let me put this in perspective. According to U.S. Department of Transportation data, the average American driver covers about 37 miles per day, roughly 13,500 miles per year. Even if you're above average and drive 50 miles daily, a 250-mile range gives you 5 full days between charges under normal conditions. Here's what most marketing materials won't tell you. Range performance scales exponentially with battery size. Pushing from 250 miles to 350 miles often requires 40 to 60% more battery capacity and cost. For a vehicle targeting affordability, that's expensive performance you statistically won't use most of the time. Tesla chose LFP chemistry specifically because it brings 3 critical advantages for long-term ownership. First, LFP batteries are significantly safer than higher-energy nickel-based chemistries. They're far less prone to thermal runaway, which is the technical term for battery fires. For someone on a fixed retirement income who can't afford unexpected repair bills or insurance complications, that safety margin matters. Second, LFP batteries last longer. Industry testing shows LFP cells can handle more charge cycles before capacity degradation becomes noticeable. In practical terms, that means the battery should retain usable range for more years before replacement becomes necessary. Third, and this is huge, LFP batteries cost less to replace if something does go wrong. A 55 kilowatt-hour LFP pack costs roughly $7,000 to $7,500 in raw materials at 2025 pricing, compared to $12,000 to $14,500 for a 60 kilowatt-hour nickel-based pack in current Model 3 variants. That's not just savings on paper, that's real financial risk reduction. Tesla isn't chasing the longest range or the most impressive energy density numbers. They're optimizing for total cost of ownership over a realistic 10 to 15-year lifespan, which is exactly how long most retirees plan to keep a vehicle. You're not buying headline specs, you're buying predictable, manageable costs. And that's a smarter way to engineer an affordable EV. Change number 3. Solid-state donut battery technology. At CES 2026, a company called Donut Lab unveiled something that could fundamentally change the battery conversation. A solid-state battery shaped like a donut. Before you roll your eyes, let me explain why this matters and why I'm covering it despite Tesla not officially confirming anything. Donut Lab's announcement included verified technical specifications. Their solid-state donut battery achieves approximately 400 watt-hours per kilogram energy density.
With donut battery, we set a new baseline, 400 watt-hours per kilogram.
Significantly higher than current LFP or nickel-based batteries. The donut shape creates a natural pathway for heat dissipation that spreads thermal energy more evenly across the cell structure. According to their published data, these batteries charge faster, last significantly longer, and operate reliably from negative 30 degrees Celsius to 100 degrees Celsius. Now, here's where engineering reality meets marketing hype. Solid-state batteries have been just around the corner for over a decade. Major automakers have announced partnerships, startups have burned through billions, and production timelines keep slipping. Healthy skepticism is absolutely warranted. But Donut Lab's approach is different. They're proposing a hybrid architecture where solid-state cells handle high power demands like acceleration and fast charging, while conventional cells provide bulk energy storage. If Tesla were to adopt a similar principle, even partially, here's what could change under optimal conditions. A 55 kilowatt-hour pack with even 20% solid-state cells could potentially deliver 300-plus miles of range instead of 250 without increasing pack size or weight.
Higher energy density means more range from the same physical volume. Faster charging becomes more practical because solid-state cells eliminate the liquid electrolyte that causes heat management limitations in current LFP batteries. And for older drivers, extreme temperature performance matters. If you live in Florida, where summer temperatures regularly hit 95 to 100 degrees Fahrenheit, or in parts of Texas or the UK, where winter cold affects battery performance, a battery that works consistently across those extremes removes a major source of anxiety. Tesla hasn't confirmed they're using this technology, but credible companies are now demonstrating working prototypes at major industry events, which means this is no longer science fiction. It's engineering that exists today, even if mass production remains a challenge. That's not hype. That's documented progress you should factor into your decision.
Change number 4. Physical buttons return to interior. Tesla is stripping the interior down to essentials, but not in the way you might think. The rumored 10.5 to 11-inch touchscreen is smaller than the current 15-inch displays in Model 3 and Model Y. Seats will likely use fabric instead of vegan leather. Heated seats may disappear entirely. The panoramic glass roof is probably gone, replaced with a conventional metal roof to cut costs. But here's the critical change most coverage is missing. Tesla appears to be bringing back physical buttons for essential functions. After years of pushing everything onto touchscreens, forcing drivers to navigate menus for basic controls, early prototypes suggest Model 2 will have dedicated physical buttons for climate control, hazard lights, and other frequently used features. Why does this matter so much for older drivers? Touchscreens require you to look away from the road, find the right menu, and tap precisely on a moving screen while driving. That's genuinely difficult if you have arthritis, reduced fine motor control, or just want to adjust the temperature without taking your eyes off traffic. Physical buttons provide tactile feedback. You can find them by feel, operate them without looking, and know immediately when you've activated the right function. Voice control remains fully integrated. Tesla's voice command system has improved dramatically and now handles most common requests reliably. You can adjust temperature, change navigation destinations, or control media playback without touching anything. The Tesla mobile app also stays fully functional, letting you precondition the cabin, check charge status, or locate your vehicle from your phone. And perhaps most importantly, the FSD platform remains available. Tesla isn't removing the hardware capability for advanced driver assistance features. The sensors, cameras, and processing power stay in place, which means features like automatic parking, lane keeping assistance, and adaptive cruise control should still function. What you lose are premium touches. Ambient lighting gets simplified to a single color instead of customizable options. The speaker system will have fewer drivers, affecting sound quality. Storage compartments might be less refined. But the core functionality that actually helps you drive safely and comfortably every day stays intact. This is a crucial distinction. Simplification doesn't mean removing useful features. It means removing complexity that doesn't serve the primary mission, getting you from point A to point B safely, comfortably, and affordably. For someone who's been driving for decades and just wants a vehicle that works reliably without requiring a technology degree to operate, this is actually a significant improvement over Tesla's recent direction. Simple isn't outdated. Simple is smart design for real people.
Change number 5. Manufacturing innovation drives pricing.
Let's be very clear about what $12,749 actually means. That's the target price point Tesla is fighting to reach, not through gimmicks or corner cutting, but through fundamental changes in how electric vehicles are designed and manufactured. Getting to that number requires solving problems traditional automakers have struggled with for decades. So how does Tesla get there when traditional automakers can't? Gigapress technology is the foundation.
By casting large sections of the vehicle structure as single pieces instead of assembling hundreds of stamped and welded parts, Tesla eliminates entire layers of labor, tooling costs, and quality control checkpoints. Industry analysts estimate large-scale casting can reduce structural assembly labor by 20 to 30% in affected sections. That doesn't make the whole car 30% cheaper, but it fundamentally reshapes the cost structure in ways traditional assembly lines can't match. Unboxed assembly takes this further. Instead of building the entire vehicle on a single moving line, different modules get assembled in parallel by specialized teams, then combined near the end of the process. This dramatically increases factory efficiency and reduces the physical footprint required. Here's where the savings add up. The small battery pack saves approximately $6,000 to $8,000 compared to larger EV packs. Simplified interior and reduced features save thousands more across materials and labor. Then add available incentives. The federal EV tax credit provides up to $7,500 where still applicable. Some states offer additional rebates ranging from $1,000 to $5,000. Certain utilities provide further incentives for EV adoption. Combine aggressive engineering cost reduction with every available incentive program, and $12,749 becomes mathematically possible for qualified buyers. It's not magic, it's not accounting tricks, it's extreme optimization across every dimension of vehicle design and manufacturing. Tesla isn't selling cheap, Tesla is engineering differently, and that difference shows up in the final price.
Change number 6. Driver assistance remains standard. One of the biggest misconceptions about a low-cost Tesla is that it won't include advanced driver assistance features. That's wrong. The hardware foundation costs relatively little to include during manufacturing. The cameras, radar, and processing chips are already integrated into Tesla's production process at scale. So even at this price point, Model 2 should include core safety features that actively help older drivers every day. Automatic emergency braking detects potential collisions and applies brakes if you don't react in time. For drivers whose reaction times have naturally slowed with age, this is a genuine safety net. Lane keeping assistance gently steers the vehicle to stay centered if you start drifting. On long highway drives where fatigue becomes a factor, this reduces mental strain significantly. Blind spot monitoring and rear cross traffic alert provide warnings about vehicles you might not see. These features compensate for reduced neck mobility or limited peripheral vision. Adaptive cruise control automatically adjusts your speed to maintain safe following distance. In stop-and-go traffic, this eliminates the constant acceleration and braking that causes leg fatigue. Smart parking assistance can automatically steer the vehicle into tight spots, removing stress about parallel parking or scraping curbs. Advanced full self-driving features requiring a subscription will likely remain optional, but foundational driver assistance features that improve safety and reduce fatigue should come standard. Here's why this matters. These systems reduce the cognitive load of driving. They handle routine tasks in the background, letting you focus on the road ahead. For drivers concerned about maintaining independence but realistic about their changing abilities, these technologies extend safe driving years. The car quietly helps you stay safe without making you feel like you need help. That's dignity-preserving technology design. And it's available at every price point Tesla offers.
Change number 7. Total ownership cost prioritized. Let's talk about what really matters when you're living on a fixed income. Total cost of ownership over time, not the purchase price. Electric vehicles eliminate most routine maintenance that gas cars require. No oil changes every 5,000 miles at $50 to $80 each. no transmission fluid services, no timing belt replacements, no exhaust system repairs, no spark plug changes. According to multiple ownership cost studies, EV owners spend 40 to 60% less on maintenance and repairs over the first 5 years compared to equivalent gasoline vehicles. Brake pads last dramatically longer because regenerative braking handles most deceleration, capturing energy back into the battery instead of converting it to heat through friction brakes. Many Tesla owners report original brake pads still have 70 to 80% life remaining after 100,000 miles. Tire wear is comparable to gas vehicles when properly maintained, and because electric motors deliver smooth, predictable power without engine vibrations, the overall driving experience involves less mechanical stress. Insurance costs for EVs have traditionally run higher than gas cars, but smaller, simpler EVs with lower repair complexity should compress that premium over time. Energy costs tell an even more dramatic story. At average U.S. residential electricity rates around 14 cents per kilowatt hour, charging an EV costs roughly equivalent to 40 to 60 cents per gallon of gasoline when converted to miles driven. Even with some public charging at higher rates, most EV owners pay less than the equivalent of $1 per gallon. Compare that to current gasoline prices between $3.50 and $4.20 per gallon in most states, and a typical driver saves $5,000 to $7,000 on fuel alone over 5 years. Battery safety is another factor most coverage ignores. LFP batteries are significantly less prone to thermal runaway than other chemistries. They're more stable, less reactive, and pose lower fire risk. For someone living in a retirement community or parking in a shared garage, that peace of mind matters. Add it all up, and you're looking at a vehicle that costs less to insure, less to maintain, less to fuel, and less to worry about mechanically. That's what a good retirement vehicle should deliver. Predictable costs, minimal surprises, maximum independence. Model 2 appears designed specifically for that mission.
If you've watched this far, you didn't just watch an advertisement. You just watched a serious technical analysis. If Tesla Model 2 actually launches around the $12,749 effective price point, it won't be the most exciting Tesla ever made, but it could be the most practical Tesla ever designed for retirees and people living on fixed incomes. Not the longest range, not the flashiest features, not the most impressive specs, but the most honest vehicle Tesla has ever attempted to build for real people dealing with real budgets and real physical limitations that come with age. Now, here's what I need from you. If you want to keep watching videos that explain clearly, without clickbait, without dream selling, and without wasting your time, subscribe right now and turn on notifications. This channel exists to help you make informed decisions, not to sell you hype. And leave a comment answering one of these questions. If Model 2 launches at this price, would you seriously consider buying one? Comment yes or not yet.